Hi, I'll be presenting our paper removing the quality tags in controllable face generation. Conditioning a pre-trained generative model is hard because the factors of variation in a dataset are spuriously correlated. We see this even using state-of-the-art inversion techniques like high-fidelity GAN inversion, or HFGI, by Wang et al., where varying the head pose leads to strong artifacts, and varying facial expression leads to changes in identity and the appearance of glasses. Conditioning from scratch is also hard. Compared to StyleGAN 2, conditioning with existing face models like a 3D morphable model or 3D here. In DiscoFaceGAN produces worse sample quality, confirmed by a large FID gap. Deng and colleagues claim that this quality degradation is inevitable and is a quality tax we pay for controllability. We discovered that the quality tax is actually caused by poor conditioning of the generative model. We fixed this to achieve tax-free 3D conditional face generation where we obtain high-quality results even with large pose and expression variation. Correct conditioning achieves two things: consistency and disentanglement. Consistency induces a semantically consistent change in the generated sample. When generating a sample X using generator G and noise Z, if the condition in P is a smiley expression, then we want the generated face sample X to look smiley and not angry. InfoGAN formulates this problem as maximizing the mutual information between the condition P and the generated sample X. The mutual information can be directly optimized if the posterior P given X is tractable. For disentanglement, we want the condition to induce no change in any other attributes not controlled by the condition in the generated sample. If we change the condition P to be smiley, we should not suddenly change the identity of the person. Suppose we have conditions P1, P2 through Pn, where each controls the semantic attribute of the generated sample. We want the variation caused by one latent code Pi to be irrelevant to any other latent code Pj. Peebles et al. Observed disentanglement through the second derivatives within the generator network. The first derivative describes the variation caused by one latent code, and if the second derivative is 0, then this variation is irrelevant to any other latent code. Let's apply this to human faces. The unconditional StyleGAN 2 takes noise Z and turns it into a sample X. DiscoFaceGAN conditions StyleGAN on a 3D which is a multilinear model from computer graphics over identity, expression, illumination, and pose. It concatenates the 3D vector P and noise Z as input to the mapping network. An ad hoc objective named imitative loss is enforced between the sample X and the 3D render to ensure consistency. But this struggles to correctly condition the generation because the domains are different, leading to worse sample quality. Unlike DiscoFaceGAN, our method feeds the 3D condition P as a separate branch to the synthesis network. This design is crucial to disentanglement. Then we directly optimize the mutual information as our consistency objective instead of relying on ad hoc losses. We note that consistency is achievable if the posterior is known. In our case, the posterior corresponds to 3D face reconstruction. Any approach that can estimate 3D parameters from an image makes it feasible to estimate the posterior. Disentanglement is more challenging. While it could be directly optimized via a Hessian penalty, this leads to an obvious drop in quality. Instead, we approximate the 0-second derivative conditions by the inductive bias of a carefully designed network architecture. The key insight is the locality bias of a convolution encoder, which leads to sparse first derivatives. This approximates the disentanglement objective without any explicit penalization. And that's it. 3DMM is a powerful conditioner. We can see subtle expression changes, illumination, identity, and camera pose changes, still from a 2D generator. And our method closes the gap in FID while also maintaining disentangled control over 3DMM parameters, effectively eliminating the quality tax. Thank you. Any questions? We measure the disentanglement score by Deng et al. Of our model and compare it with DiscoFaceGAN. Our model achieves better disentanglement. On the left, we show results of variant Z while keeping the 3DMM condition fixed. We see high facial consistency while the hair and background completely changes. On the right, we show results of varying 3DMM condition while keeping Z fixed. We see high consistency in background and clothes, yet the identity of the generated images completely changes. For reference-based generation, we keep the identity 3DMM condition fixed while using other 3DMM conditions from the reference image. For real-world image frontalization, our model achieves the best photorealism and pose accuracy. We showed the derivation of our consistency objective. Note that the entropy of the condition P is not optimizable and therefore a constant. For more details, please refer to equation 4 and lemma 5.1 of the InfoGAN paper.